Good. Hey, first and foremost, I'm going to thank everybody for showing up. Thank you for coming out to the facility. Thank you for coming out for our first MyFuel demonstration. Wanted to thank the VanGen Group as well as GFS Corp for coming out and partnering this project with us. And once again, thank you all for coming out. A little bit of info about Depco Power Systems. We founded this company in 1991. Dick Davis, Tim Pelty, and Tad Stickler started the company. We originally started basically just in the export business, selling Detroit diesel engines, blocks, cranks, heads, turbos. From there, moved into the Cummins K series. From there, grew the company into, started to deal with Caterpillar, started to deal with Cummins on the marine side as well as the power generation side, generator sets, marine engines, so on and so forth. As we go on, what we're going to do this morning is I'm going to let Kyle talk, or James talk just for a second. After that, we're going to go ahead and let GFS run you through a little bit of a demonstration. If you've got any questions for anybody at any time, please grab one of the guys in the Depco shirts or the VanGen shirts or the GFS shirts. We'll go through that demonstration, then we'll go ahead and do a live run. From there, we'll go back and we'll have a question and answer with the engineers. From after that, we'll grab some barbecue and let everybody mingle. Thanks again for joining us, and right now I'll give the floor to James.
Welcome, everybody. So my name is James Guerra. My partner, Kyle Reynolds, over here. We're part of the VanGen Group. We started our company a little less than a year ago. We're power generation guys at heart. We've been doing this for 13 years, respectively, I guess, in the industrial equipment market. So we're a manufacturer rep firm for the power generation industry, electrical contracting market, and oil and gas. So we want to sincerely thank Mr. Dick Davis and his group for opening up this event for us and investing the time and money to demonstrate the MyFuel technology. So we appreciate it, Dick.
Thank you.
With that, we brought in Chert Nampone. He's the applications engineer for GFS Corp. He's the mastermind behind the technology, and will be running us through the presentation, the live demo, and then the Q&A afterwards. So feel free to get Kyle and myself or any one of the Depco guys to talk about the system and answer any questions that you guys may have. So thank you again for coming out and spending the time with us. We appreciate it. We know it's tough to get out and tear yourselves away from your desk to come visit with us, but stick around. We're going to have barbecue at lunchtime, and then for those that are going to stay in the afternoon, we'll have drinks to follow. So those of you that need to drink early, let us know, and we can open that up to you.
You can come back.
Well, so
The beer's open already, so
yeah. So thank you again for coming out. So we'll let Chert run through the presentation for maybe 15 minutes or so, and then we'll start the engine.
Oh, I think everybody's waiting for it, so we won't take that long. But again, thank you for coming out, and want to recognize Mr. Dick Davis. And thank you, Dick, for setting this up. It's looking very impressive. Also, Mr. George Agrell just arrived. He's the vice president of the GFS. And I have Arnold Yanes, our field engineer, that's been helping me for the last couple of weeks. What you see on the PowerPoint display is we just want to point out some of these components that have been installed on the engine. Just a little bit of short history for GFS. GFS started out with the Mr. Ken Green and Jason Green, father and son. And myself been working together off and on. I used to work with another company, but been involved with the Greens for the last 18 years. But now finally we formally joined forces, and I'm now working for them, with them under the GFS flagship now. The product that we have available from the GFS Corporation is that the natural gas plus diesel conversion kit. This kit designed for any diesel engine, whether it was going to be a stationary power, just like what you're seeing here on your left, or a mobile application, such as those on a train or locomotive, trucks, boats, any mobile application we could think of. We have a very, very significant success with the application on the mining trucks. Now, when we talk about trucks, these are dump trucks, but they are like 400 tons, 200 tons, 400 tons, and some of them are even larger for the equipment. They're using you're thinking of a truck, you may not envision that, these trucks use very large engine like Caterpillar 3516, or even this QSK 60 you see here being used on those dump trucks. And they consume a lot of fuel, diesel fuel that is, and the price of diesel fuel is going up every day, so the more we can displace that diesel fuel or replace it. That's why we call our product natural gas plus diesel. Okay? Some of the component here is that, that's a very short, quick history of the company. Go back to the other slide. Yeah, right there. Right, no, okay. The Evo, this is our trademark product, Evo products, and as you can see there, there's a MT for mine truck, okay, and the LT that for locomotive transportation. SP is stationary, which is you have here, so we highlighted in larger. The SP system is for stationary power application. And we have the RT, which is the refrigeration transportation equipment. And also the HT, which is the highway transportation equipment. So yes, we have all of these products that will be available for all of these applications. Okay. Can't really see what that is, so if I step up front here, maybe I can stay on the subject. Okay. What are the benefits? I think most of us know this already, so a quick review, right? Substantially reduce the fuel cost, extended runtime for emergency application or standby application, clean burning, more sustainable natural gas, patent pending on several of the feature and function in our product. We have dynamic set point protections, and that is the set point that is floating with the engine operating condition. You may be more familiar with the absolute set point, where it's a very high set point. And so under that scenario, you are compromising the set point for lower load range. Understand, right? For instance, the EGT, exhaust gas temperature. The absolute high for exhaust gas temperature for an engine like this may be 1350. So that's what would be the set point. A static set point would be that 1350. Given that same engine at 500 kilowatt, the set point should be lower because the temperature can be operating at much lower. And that's what the dynamic set point, what we imply as being a dynamic set point. The set point is floating up and down with the engine condition. Basically the engine load. Okay. 50 to 75% set point substitution. That means how much we can displace the diesel fuel or replace the diesel fuel. Some engines have the capability of taking or accepting this natural gas more than the other. And a few years back, I was the one that set this precedent of not going to go more than 70%. Basic reason for that is it's for the engine safety. It's not difficult to put natural gas into a diesel engine. There are several ways to do that, but to making it safe, it's a different story altogether. We found out that from experience that if we don't reduce more than 70%, we don't change that performance characteristics. Number one. Number two is the engine life. We don't affect the part. We will have no premature part if we don't remove more than 70%. So 70% is set as a maximum to maintain a total of 100% diesel engine characteristics. And maintain the OEM performance. Some cases we can even make it better, but it's not advisable or not recommended. Okay. The car components. Some of you have been walking around the engine. This is the air-gas mixer with the integrated throttle body. That throttle body is just, I think it's kind of self-explanatory. We are throttle gas going into this mixer. So we are actively controlling the gas flow into the mixer, in turn going into the air manifold and going to the engine. Okay. We have the 5 to 8 inch range. We also even increased it to 10 and 12 inch now, the size, diameter. 1.5 inch, that is the connection, the JIC connection, or the end of the gas delivery hose. We have a 1.5 inch JIC connector on it. And for linear control, we use the linear signal, 1 to 5 volts, 4 to 20 milliamps control signal to throttle these gas control valves or throttle. And to simplify and maximize the control characteristic of our system, we have developed or designed this new device called the mass airflow sensor. So we are measuring the mass airflow into the engine, and we map the fuel flow to that data that we receive from the mass airflow sensor. And this is one of the things that I mentioned, under patent, we're going to have this mass airflow sensor patent under GFS Corporation. Okay? Yeah. Oh, okay, yes. James pointed out very good here. Right now, we have capability of controlling up to 6 throttle body, so we can, accommodate the 6 turbocharger engine, like what's it, NTU 4000. Let's have some of those have 6 throttle body, 6 turbocharger. This one here had 4, so you will see 4 throttle body on this. When we switch to the display mode on the screen, you'll see that there's the position indicators that will tell you where each of the throttle body position, how much is open or how much closed. The next component is the ECU, the electronic control unit. So 32-bit microprocessor, have the J1939 Modbus capability. We program all of the fuel mapping that I mentioned earlier. So we measure the airflow and we match our mapping, how much fuel we want to allow going to the engine. That mapping is then programmed into the ECU, and the ECU taking care of that. The ECU is we're monitoring that's greater than, between more than 25 sensors. What are these? Pressure, temperature, and vibrations, not those that is critical to engine safety. We monitor those sensors, and we brought it in and process them and set the set point and send out the control command signal to the throttle body to get the gas flow into the engine. The display is it's a fully touchscreen, fanless, full PC type of a display. We have a quick virtual dashboard to allow you to view those critical data. And when the set point is violated, we have 2 set points for each of these sensors, whether it was pressure or temperature or vibration. The alarm set point, you will see a yellow in color that turns the signal. That yellow meaning that now gas is shut off, but it's not locked off. So once that condition is clear or safe again, gas will be turned back on again. Once you see the red, such as that temperature right there, that's a vibration. Once it's red, it's going to lock off for good. So now it's too dangerous for that engine. It will need some intervention or interrogation to see what had caused that reason. And then once it reset, it had to be manually reset for some of these latched condition. Then the system will be turned back on, but it will not come back on automatically. Okay. This is the gas stream, and we are requiring anything from 1 to 5 psi gas inlet to our gas train, and that gas train is factory pre-assembled and pre-tested for leak and performance. Once it's installed, we have a pressure inlet that we are monitoring, the pressure inlet and pressure outlet. This is the double solenoid valve type that doesn't need block and bleed, such as some of the, when you think of a gas application, it should be block and bleed, but under the code, if you have double block valve, you don't need to do block and bleed. Next. What are some of the safety features? I think I covered a lot already. The dynamic set point control. We have also employed a flame detection to detect any fire, just in case of a fire, the system will be shut off. Combustible gas, should there be a gas leak, and the system will also, we can generate set point to shut off the system. High exhaust high loose pressure, high vibration, that's with the engine knocking, and then excessive diesel flow or gas flow, and the throttle body position feedback. We can monitor that feedback and allowing a certain amount of error. So let's say that we said we should go to a 30% position, and we can put in, let's say that 1 degree of error. If it goes to 29, that's not good enough. We can shut off the system, assuming that the reason for the position not being at the command position is there is something wrong, something unhealthy about that particular control valve. So, okay. That's it. There's contact information here. There's a lot of brochure sitting here. Pick up those, and just by talking to us, we are also on the web. You can go to www.gms-corp.com. Most of the information is on the web. And, yeah, we can throw up the control panel and explain and point out a couple of things before we start the engine for you. Okay. What you going to see on the display is we have the first one here is labeled as load. Actually, that is a dual gauge purpose for the application that we are using in KW. That will be a measurement of an engine KW. For right now, that would be a mass airflow. You can see the unit will be the cubic foot per minute. Yeah. And then there's be a gauge to show you the gas substitution. MAC is manifold temperature, 1 and 2. Right now, number 1 is measuring just the ambient around the engine. Number 2 is the actual air manifold temperature going in the engine after the cooler. And the next one here is GSP, that's gas supply pressure. It's in PSIG. The next one is GOP1 and GOP2, that is gas outlet pressure. We have 2 gas trains on this engine, and we are monitoring each one of them separately. Each one of them have a safety set point should that gas pressure climb or increase beyond the safety condition, then we will shut the system down. Okay, that's its TBP, that's throttle throttle body position. You'll see a floating column indicator that comes up to tell you where the position. And the VIB, that would be the vibration sensor. Okay, there are 4 of them, but through the course of testing, we lost one. So now you must see only 3 readings on the vibration sensors. Diesel is not connected, so you will not see a diesel flow. You'll see a gas flow here in cubic foot per hour. And then MAP would be manifold pressure, and we only connecting 1, so you'll see 1 working and half of it is not. Over here is the EGT, exhaust gas temperature. You see 6 columns here, but we only attach or just install 4 sensors. So you'll see 4 temperature points here. Over here on the upper right-hand corner here, you will see a couple of information data there. Right now, the system is off because there's no mass airflow. That's what that means. Once we start the system up, and once the mass airflow reaches the minimum set point for turning the system on, this word will change from off to on, and you'll start to see the movement come over here. The throttle body will start to move up, the gas start to move up. Okay, so it's going to be quite noisy, so that's why I explained all of this, so you'll see that's what's going on. Any questions?
Yeah.
Yes.
Do you mix the diesel and the gas, or you injecting diesel and gas separately?
Okay. The question is, do we mix the diesel and gas? No, we don't mix the diesel and gas. We mix the diesel into the air. So we're blending gas into the air, and the air is then going into the cylinder.
So you have
Yeah.
two different supply systems, then, one for the diesel, one for the gas.
Yes. We don't tamper, we don't change, we don't make any change to the diesel system. That is still remain as 100% diesel engine. We introduce the gas into the airstream by using our mixer. Okay, so gas is going to mix in with the air and then goes into the engine. Yes.
What have you seen on your emissions levels?
Okay. The last 20-some years, quite clear that the picture of emission for a natural gas plus diesel engine will be, number one, NOx will be reduced, anywhere from 10 to 35, 40%, depending on the engine, depending on the service fee. CO will go up significantly. CO2 will be reduced. Particulate, will be reduced. Non-methane will be reduced. Methane will be increased. So there are two items here that will be increased from its normal diesel condition. Okay, so that will be CO and methane. Unburned methane. Okay. Anything else? Yes.
How do you reduce the diesel back once you burn the gas?
Okay. How is diesel being reduced? This is an isochronous governor engine. All that it wants to do is maintain the engine RPM at 1,800 RPM. Once we introduce the gas, which is an added energy, that RPM tend to increase, and the governor only know what to do with keeping it at 1,800 RPM. It will try to decrease, and the only thing that it can decrease will be diesel. So that's how we decrease the diesel. We don't have to do anything.
So the factory diesel injection system will reduce it back on that?
Exactly, because of that isochronous governor, yes. Yes.
It can work with propane and natural gas.
Okay. Can this system work with propane? The answer is yes. You will not get a great reductions as you would with the natural gas, because the propane has a little bit quicker burn rate, and therefore you can't put as much in there. What happened is that the engine will start to knock sooner. So let's say that given the same engine that you will be able to replace 50% diesel, switch to propane, you may only get 30%, 35%, maybe at best will be 40%. So that will be a great reduction in substitution if you use propane. Yes, I think there was a hand back there. Oh, photographer. Okay. Anything else? George, you have anything to add?
I don't have anything, but if anybody has any questions, feel free to look me up. I'm the vice president of DFS, so I've got kind of overall responsibility for this product line and a couple of others.
Another question.
Yes. Question.
Is it the sample? Is it sample?
Sample.
Soundproof.
Oh, soundproof. That's really doesn't have anything to do with the conversion kit. The soundproofing would be in an enclosure such as this. The reason that unit is not installed in a soundproof enclosure is for the purpose of demonstration, that you can walk around so you can get a bit of picture of it. But eventually, all of these generators you can order with it soundproof enclosure. Yes, that's a thing. I'm sorry, I just answered that question for you, Dick. Yes.
What's the average cost?
Pardon me? Average cost. I think you have to get with Dick or James over here. I don't get involved in that cost. Yes.
How long it takes to install one kit like this in a basement? How long it takes?
How long does it take? Okay. How long does it take to install a system? A smaller system will take a lot less time. This system you saw here, there are 4 mixers and 4 mostly of everything. It took 2 days to install that system right there. Yes, and maybe another day to commission it. That's in the general rule of thumb, generally speaking. Yes. Yes.
What's the gas pressure and the BTU content you need?
Okay. Gas BTU and the gas pressure and the BTU content of gas that is needed. Okay. Basically, we require 1 psi to 5 psi inlet to our gas stream. Okay, so that's the pressure. BTU, I'm not going to say the higher the better. The more methane it is, the better the substitution. However, the conversion kit can work with 500 BTU or 1500 BTU. Okay, so it doesn't really know. It doesn't care about the BTU content. In generally, pipeline gas is going to be somewhere close to 1,000, maybe 950 to 1,000 BTU. That's close to being pure methane, so it will get the most benefit when there is more methane in the gas. Okay. Yes.
How reliable is the system, and what type of component failures within that ecosystem that you guys have anticipated? And if it fails, does it just revert back to all diesel by itself?
Very good question. Yes. How reliable is it? No, it has to be very reliable. We're trying to make things very simple, because the simpler it is, the more reliable it will be. The fallback for this type of technology is 100% diesel, and therefore, anytime that there is a hiccup or the system has to be shut off, it's automatically revert to 100% diesel. So there will be no service interruption. Yes.
There's all kinds of different gases, as you mentioned. We have a pipeline quality flare gas. Do you have a way to model performance based on a gas analysis that would be used?
There are some predictability to it, yes, since we have quite experience through the years. However, that is only one of other factors as to how the final performance will be. The way the engine is packaged itself, the type of the engine, and also the service duty of that particular package. These are all factors that will affect.
Given all that information, that we give you all that information, we have a package, we give you how it's packaged, all this, maybe you have a checklist,
Yes.
and then gas quality. Can you predict
A rough
Okay.
estimation, yes, we can give you that. It will not be an accurate one, because that would be somewhat of a promising, and we won't promise anything. I'm sorry. Almost people even ask, can you give us a guarantee that it will do this, this, this? No, there's no way we can do that. Since there are other factors that we are totally out of our control. The engine life, the engine condition, that's also take care of that, and the surrounding temperature, the surrounding.
So if you're using anything other than pipeline quality gas, you're kind of taking a risk there.
Most of the effect is going to be a reduction in substitution, yes. Whether it was lower BTU or higher BTU, once the BTU is deviate from that, let's say the pipeline standard, the effect would be reduction of substitution. Okay. Yes.
How much volume of domestic gas will this system use to run for like 24 hours?
Okay. The very, very simple. Well, the question is that how much gas would one need to run 24 hours? Okay. The rule of thumb is this: you can use approximately, just give yourself a little bit of a factor here, about 8 cubic foot per kilowatt hour. So if you have 100 kW engine, you will need 800 per hour. So 24 into that, 24 hours would be 800 times 24, or 100 kilowatt engine.
That's a rule of thumb that we use and that we recommend when it comes to sizing the gas piping going into the engine.
It's used slightly less than that.
Use it.
Yeah. It's used slightly less than that. Actually, if you get closer to it, it's actually approximately point. For this engine here, we just found out yesterday, we'll talk about, this engine here would be 0.069 cubic foot of gas per kilowatt. Okay? And that number is simple. You just do math. Okay? This engine here will do 141 gallon per hour at fully loaded. So you take 141 divided by 2,000, you get 0.069. That 0.069 is the amount of diesel you use per per kilowatt. You take that number, multiply it by 130, which is the difference between the diesel and the gas in BTU, and you will get the amount of gas that for 100%. You multiply that number by 0.5, that would be assuming that it will be 50%, and you'll get that gas for. Yes, you have a question. Yes.
Yes. What about the maintenance?
The maintenance?
Yes.
Okay. The only moving part in our system is a gas throttle, the throttle body. Okay. The throttle body is quite robust. It's made for an engine speed control. So that's the only thing that I see that it may be a shorter life comparing to anything else. Everything else is a no moving part. It's just a gas regulator, solid state electronic controller. If you don't step on it or you don't mount it where it's excessive heat or excessive vibration, we have not yet seen any normal service life. We have one on the truck for how long?
What, vibration?
The ECU.
Been running for at least 8 months.
Yes. The ECU is mounting on a truck that's been running for 8 months. Mine truck now. I say truck, it's not truck on a pavement on a highway. It's on the dirt that go up and down and bouncing around all day long. So and they didn't require any maintenance for the ECU or the sensor. So really very, very low maintenance. That's to answer your question. Yes, you also have a question, sir.
CNC or NO?
Okay, CNG or LNG. All right. By the time the gas gets into our gas train, it has to be gaseous form. So if you have LNG, it has to be evaporated, have to be vaporized into gas. So it's only gas form. But it doesn't. In saying that now, okay, and then would answer is that it will be CNG. In this case, pipeline gas. It had to be in gaseous form. If you have LNG, it had to be evaporated, re-evaporated to gaseous form, right? Okay. By the way, LNG would be perhaps the best fuel for it because that is very, very close to being pure methane. Yes. Okay.
Sure, you'll go ahead and run it.
Yes. Okay. All right. Let's start the engine, and then we can come back for question again after we run the engine for a while. Okay.
If anybody doesn't have any hearing protection, we got more. Hey, Joe.
mechanical injection type? Not really. We have seen that it works on all of those that we mentioned. The difference that it makes is that perhaps on some of the more complicated control type, that it had caused some substitution to be reduced somewhat. Some of the function of the engine ECM, one thing that we found out earlier in the game is that with the MTU that have a half engine condition or half engines feature, that need to be turned off, or at light load that would come into interfere with the system, depending on where that half engine feature is set at. So most we have just asked that to be turned off. Okay. Yes.
Someone asked me earlier, with this system, can you run a lesser rate of gas, natural gas, and put on a straight natural gas engine? Or is it still quality gas has to be up at the same level?
Okay. Very, very good question. Can we use less quality gas with this system? That's what the answer is yes, and that's where it would, where we would shine, because let's take the 100% gas engine and you have 500 BTU gas. You will be very hard pressed to get, a 50% out of that engine with that type of gas, you see. But these, it doesn't really care. You can put 500 BTU gas into a diesel engine and it will take all of that, and it will take that and reduce the diesel as much as it can do. So this is where the benefit is on this type of technology. You don't really have to have a good gas, let's put it that way, but however, it has to be somewhat clean and dry. You don't want to put a lot of condensation, you want to put a liquid in, okay? That was a good question, yes. Whoever came up with that. Well, some of the demonstration probably have generated some questions, and I have been answering those already on individual basis. Okay, are there any other questions? You've seen it was a treat. I didn't really intend for you to see the yellow column, but you saw it. Okay, well, benefit of that is this: it's proven to yourself that it doesn't hurt anything. The gas can be turned off right in midstream of 1000 kW. Right? Then it came right back on, and it goes off again. And the reason being is that at that power rating, I had the set point set too low. So it's tripped it off, and then since it's being in alarm condition, it never did lock it off completely. It came back on when it cleared. So you can see the gas oscillate on and off, but then the engine didn't miss anything. It just keep on going. Okay? The other question was that, when I was running at 1000 kW, this meter read about 47. Well, that's not really 50% of the 2000, right? Well, this gauge is actually not a kW gauge. This is the capacity of my airflow meter. So it was about, at 1000 kilowatt, it would be about 47% of my airflow meter. Okay, my mass airflow sensor has capability of like around 2000 something. And the question also was, this diesel flow meter was never moved. So yeah, some of you missed it. That was disconnected. That was not connected, so it will not gonna work. Now, normally that's what we use to indicate substitution. It just so happened that on this application, it did not work. It failed. So you see that we use the gas flow meter then. In place of it, we just calculate backward how much gas is used, and then calculate from that to become the substitution. And it's just, again, very, very simple math. If you are generating 1000 kilowatt and you're using gas equal to do 500 kilowatt, then you are at 50-50. Okay? It didn't hurt anything, yes. You still get the information that you need. It doesn't affect the performance. Anything else?
Any other questions?
Yes, I noticed that your agencies, they generate, they sell these on and components. Okay. I know that it's
Yes, yes. Any diesel engines, yeah, does not particularly for Cummins or Caterpillars. Any diesel engine, yes. You also saw the capability of block load testing, right? Yesterday we were doing 1,000 and 1,500. I don't think we need to do that this morning, but 750 was okay. And you can see there's no apparent difference. It's just like any other diesel engine. The reason being is that gas is always follow diesel. So diesel is always there as a first fuel. Pardon me?
Two-stroke Detroits.
Okay. We have installed some on the two-stroke Detroit, and it's very much the same. It doesn't affect it that much. Yes.
Any other questions?
Yes.
There we go, Mr. Donald.
Pardon me? How many units we have installed installed in the field? We have 4 on drilling rig, and we have 2 on stationary power standby, and this is what does that make? 7 ones, yes, okay. However, we were the one that developed technologies already have over 4,000 installed. Just happened to be, yeah, it's a different brand, and also we make much improved to it. So if those 4,000 work out in the last 18 years, watch out for these next 2,000, 4,000 that we're going to put out in the next couple of years. Yes.
Does the ECU have any capabilities of communicating with an engine controller or a generator controller for fuel flow or any other monitoring that they might do separate from what the ECU does?
Yeah, it does. We have J1939 available, and so that if that engine ECU would broadcast J1939, we can read from that, and we can use that information.
You can pick up the diesel flow through the engine.
That is correct.
And
Yes.
if you wanted to monitor water temperature or anything else through there, you could add it in.
That is correct, but it's not our ECU is not intended to do that. This is specifically for gas, what you call it, substitution. We do have a different product that can monitor all of that.
The diesel flow side of that 1 meter can be picked up off of it rather than
Yes.
a separate flow meter.
Yes, yes. Now, in saying that, we had to debate about it a little bit because we also use that information for safety, and so how much we're going to rely on that information is yet to be decided. So far we prefer to put our sensor in because we know that is safe, and that's one of the major reason, for engine safety. All of these sensors basically they are for engine safety. The only sensor that we need for performance is just a matte airflow sensor. The mass airflow sensor, we map that airflow, gas flow off of it. That's the only one that gave us performance. Everything else is for engine safety. And so, if we were to rely on that J1939, we are somewhat farm out that responsibility to the engine ECM. Now, whether we decide to do that or not, we just have to decide later. Okay.
What's your knock detectors? I mean, that's one critical thing.
Yes, we have 2 technology that we are going to employ with our system. One is what you saw here, which is a multi-axial vibration sensor. All of the engine knocking the final effect, the final result will affect the vibration base, meaning that it will increase it. You can see it right on the screen, right? When you have a real knock, you have that increase. Plus any other mechanical knocking, it will increase that sensor. Now, right now, this is what we had and what I've used for the last 20 years. So we are now testing a new technology, which is a real engine knocking device that will ignore everything else, meaning all of the mechanical vibration, it will ignore those. It will only watch for a true engine knocking, in-cylinder knocking, and that's what we're going to also offer. Now, there will be a difference in cost between the 2 technologies. This is a lot less, the others a lot more, but it would be more effective. Okay. Now, however, in saying that, this had been using for the last 18 years, as I said earlier, when I first start, to use this type of engine vibration sensor. They're basically designed for our rotating equipment. They were using on turbine, they're using on pump and electric motor and so forth and so on. And 22 years ago, when I started using them on reciprocating engine, when I was still in my past life. Yes, another question. You smell gas. Very good. I was waiting for someone to say that. Okay. Now, there is always gas going out through the exhaust. Okay? Because we are fumigating the air intake. Part of that air is aspirating the engine, right? So in the aspiration cycle, there's a little bit mixture of gas going out, yes. Yeah, how much of it? It's approximately 2%. Not much. It's still way, way below the combustible level. So it's safe, but you can smell the difference, yes. So that's a very good sense that you have, yes. All right. Any more questions?
If anybody wants to grab any barbecue, there's some back here, and then I think
Yes.
John's got a question.
Okay, have you installed any in Tier 4 interim? The answer is no. It worked just fine, but it will violate the, the rule of the letter. It worked just fine. Government contract? Well, GFS right now don't have any government contract. Yeah. Okay. How safe is natural gas fuel? That's what you're asking? The biofuel or the natural gas plus diesel, how safe is it? Okay. Well, it is very safe, and to me, it's safer than diesel. Yeah. Number one, when you have a gas leak, it rises and it goes into the air. So the less of it being combustible, unintentionally or accidentally combusted, it's very less, because when you spill diesel, it stays on the ground. You see, so you still have, sometimes you have dirt that caught on fire. That's because diesel has been spilled over there. So in that sense, it's a lot safer. Now, in the diesel engine world, people have not yet been dealing with natural gas. So that's why the question, and that's why the thought that maybe it is not as safe. It is very safe. Okay. Any more question? If there's no question, then it's lunchtime, right? Let's have some lunch, yes. Thank you. Thank you, everybody.